Okay, out of academia into the West with a PowerPoint at the speed of light and an ironic and self-mocking hi-oh silver. It's the mask professor. Oh, forgot my mask. There you go. All right. Today we're going to continue with our discussion of Chapter 7, and that is decision making. We're going to pick up with the section on page 170, which is the dependency of decision making on decision context. So, people can make good decisions when they have the appropriate resources and can adapt them to the circumstances. So, people can adapt to our different decision-making circumstances by moving from an analytical approach, in other words, it maximizes utility, to the use of simplifying heuristics such as satisficing. But satisficing is not always a good way to make our decisions. All right, so we have, first of all, we are going to talk about skill-based, rule-based, and knowledge-based behavior. So skill, rule, and knowledge-based are based on levels of expertise. All right, and then we will shift rapidly here to our camera so that we can see figure 7.3 on page 171. All right, so we have our situation, a flow of 5.8 gallons per minute combined with other flows, and the vat volume means that the vat will overflow in 15 minutes. All right, so at our knowledge-based level, our person has some knowledge of how this works. So they diagnose and identify the system state. They assess the overall goal and define the task, develop a plan, and that comes down here. Then, so that is the novice, the knowledge-based. Here in the rule-based behavior, the person knows if the indicator is above the set point, we reduce the flow. If it's below the set point, we increase the flow. Right? So they have recognition of the state and task association. What do you do if it's in such a state? What do you do otherwise? They have stored rules for that task and come down here and take action. Our skill-based behavior, well, first of all, they know to keep it at the set point and to track it continuously. Our set point is here at 5, and our indicator is above 5. So they look at the feature formation, that's the sensory input. They go to the appropriate sensory motor pattern and take action. Okay, so where the knowledge-based person has to develop a plan, comes down to the stored rules for the task, and finally takes action, our expert recognizes immediately what's happening and takes action. All right. Ugh. All right, so the skill, rule, and knowledge-based behaviors are based on the level of expertise and experience with a particular circumstance. So the extremely experienced people are processing that input at a skill-based level, and they react to the raw perceptual elements at an automatic subconscious level. They respond to cues as signals that guide their responses. People who are familiar with the task but don't have that extensive experience process the input and perform at a rule-based level. So the input is recognized as typical system states or signs. It triggers the rules accumulated from past experience, and the rules are if-then associations. If state X happens, I need to take action Y. Those associations are between the cue sets, in other words, the signs, and the appropriate actions. So, if there are novel situations, there are no rules stored from any previous experience, in which case they have to shift to operate at a knowledge-based level where they're using analytic processing with the conceptual information. All right, so our novice is working only at the analytical knowledge-based level. Right? So if they have written procedures, then you have a rule-based level that they can deal with. If they're at an intermediate point of learning, they have some rules from their training or their experience, but again, mostly it's at the rule-based level, and new situations must move to that knowledge-based processing. The expert uses skill-based behavior and moves between the levels depending on the task. So, but even with the expert, if he encounters a novel situation, he has to go back to the analytical knowledge-based level. So our effective decision-making depends on all three levels. So similar to skill, rule, and knowledge-based learning is recognition-primed decision-making, or RPD. So RPD is considered a more refined description of how the skill, rule, and knowledge-based distinctions interact. Experts can make complex decisions in very difficult situations. Those decisions are going to be associated with naturalistic decision-making, which we have discussed before. Okay, so our experts usually recognize a pattern of cues. In other words, this is similar to the representativeness heuristic. Oy vey. They can recall a single course of action which is going to be similar to rule-based behavior. And then they implement that action. All right, so this tends to be an intuitive process, giving them the capability of rapid recognition. And they're going to have a large store of knowledge to draw on. Now this relies on three critical assumptions. That experts use their experience to give us a plausible option the first time. That time pressure doesn't cripple their performance. So they have very rapid pattern matching, and like perceptual recognition, it's resistant to the time pressure. The assumption is that experts know how to respond from their past experience. So in some cases, experts will use analytical methods if they're unsure of the proper action, right? So a novel situation comes up, they're going to go back to their knowledge and analytical level to solve the problem. Now, this can be evaluated by imagining the consequences of the action. In other words, mental simulation. Uncertainty still exists, but we assume adequate time to deal with that. So additional analysis may be performed to evaluate the situation, to modify the retrieved action plan, and to generate alternative actions. All right, so factors affecting decision-making performance. This is an integrated description of decision-making. So our integrated model of decision-making combines the skill, rule, and knowledge-based model with our figure 7.2, which you remember lays out the mental model for how we react to circumstances and make a decision. So in this model, environmental cues are interpreted with automatic skill-based processing, intuitive rule-based processing, and analytic knowledge-based processing. Now, we can have skill or rule-based processes and not have a satisfactory answer. In that case, the decision is going to move upward in the model, and our metacognition, in other words, ability to recognize a larger circumstance, helps to get to the appropriate decision-making strategy. All our analytic processes rely on mental simulation to assess our hypothesis, our plan, or our action. So mental simulations identify information that we need to evaluate. We search the environment for this information. We use cognitive simulations to generate ideas and additional information, which is why people look for confirming information. But our mental models are what make that mental simulation possible. They support the evaluation process, and having accurate mental models is critical for a good decision-making process. Poor mental models can drop the decision performance by 30 to 60%. And boy, I would have loved to have seen the experiment that found that out. So, recognition of our situation is critical. So, adequate awareness of the situation is critical. Now, figure 7.4 shows us the integrated model of adapted decision making. And here we go. All right, so we're looking at in this case, we're looking at the automatic or skilled base case. The person perceives the cues and they execute actions. They will monitor the effects of the actions, and that provides feedback to, in case we need to perceive more cues because the action didn't have the effect needed, right? So the selective attention is all on perceiving the cues. Moving up to the intuitive or rule-based level, so we have situation awareness where we're integrating cues. We retrieve cue action rules. That comes over here, it goes down to execute the actions, and then monitoring and feedback proceed in the same way. At the analytic knowledge-based level, we have a level 2 situation awareness where we have to diagnose and identify the system state. That means we have to evaluate the explanation by running mental simulations, searching for more data, checking for consistency. We have to assess our goal and define our overall task, right? So that goes into evaluating the action, running more mental simulations, considering the outcome, the costs, the benefits. We come down here to developing the plan. We evaluate the plan, again with mental simulations, consider the timeline and effectiveness, comes down here to execute actions, and so on. All right, so the skill-based is automatic. In other words, they perceive the cues, they do actions. Where rule-based and knowledge-based, the working memory has to come into effect. All right. Now, you'll notice one of the features of our model was the feedback. But if we have poor feedback, we have poor learning. And that can lead to having inaccurate mental models of how the system works. Now we come up against some other problems in the form of cognitive limitations. So we might have inadequate cue integration. Right? We see cues, but we don't really put them in our schema of things. We might have inadequate or poor quality knowledge in our long-term memory, right? Which obviously it puts a limitation on controlling a system. We might adopt a single course of action without considering everything on a metacognitive level. We could have an incorrect or incomplete mental model. We might have problems because of our working memory capacity and the limits of our selective attention. We might have poor awareness of a changing situation and need to adapt or adjust how we use a rule. Okay, so our inadequate metacognition leads to an inappropriate decision strategy for the particular situation. And again, poor feedback from past decisions we've made, which may keep us from making a good decision now. Well, of course, all of this is aimed towards how do we improve human decision making? The first way that we can improve it is one we've talked about before, which is task redesign. We change the system to support better decision making, right? And that's very often an easy or at least pretty straightforward fix. We should always consider changing the system first. Our next possibility is to use a decision support system. Now, sometimes this can be things like just a simple table that elaborates on an expert system. The computer can be used to support the working memory and to perform calculations. Or we could use what are called decision support systems. Those are any interactive system that is specifically designed to improve decision making of its user by extending the user's cognitive decision making abilities. Oh, boy, okay, so there you go. Any interactive system. Now, sometimes it's hard to tell the difference between a decision support system and an information display. A well-designed information display is sometimes all that is needed. So within the decision support system paradigm, we have two different philosophies. One is we reduce the poor decisions by eliminating our defective or inconsistent decision making by the person. In other words, we call that a cognitive prosthesis. A prosthesis, as you know, is often used as a way to describe an artificial limb. So I guess a cognitive prosthesis is an artificial brain. The problem that we have with this cognitive prosthesis approach is it can't cope if we have an unanticipated condition. And very often we're going to have an unanticipated condition in life. So our other approach is to support the adaptive human decision making by giving them useful instruments to support the decision maker. These are known as cognitive tools. Again, it works well when the decision is well defined and we have no unanticipated conditions. Our expert systems are not very successful in complex situations because they use the prosthesis approach. Now, there are problems with this. First of all, having the computer do the task and the people being subordinate isn't popular. Except with computers, they love it. You can't communicate or collaborate with the computer as you could with a human. Again, we would have problems if we had a novel situation or we had poor data entry. So it's kind of a very brittle human-computer decision-making, and it's inflexible when we have unforeseen circumstances. All right, well, what we can use, another way to do it, is a decision matrix or decision trees. These are popular with engineers and managers that they use a table or a decision matrix. It supports the normative multi-attribute utility theory. But they're useful because we reduce the working memory load. It lets us consider the decision space more broadly. When we have it there in front of us, it means that we already see that there are more possibilities than the ones we have formed in our mind. So, a decision tree, we have a sequence of decisions and possible consequences. We built something similar in statistics class where we had branching depending on the number of choices for a product. So we have a sequence of decisions and the possible consequences. Each branching point is has different decision alternatives. It might be anywhere from 2 up to however many. Hopefully not too many though. So we follow by branching points for our possible consequences and the probabilities of those being true, right? So if we have 3 branches, one of them is at 70% likelihood, one's at 29%, and one's at 1%, well, we probably won't pay attention to that 1% unless the 70% or the 29% don't work out. The problem with a decision tree is always in user acceptance. A lot of times people don't see the utility of that right away. That brings us to the excitement of spreadsheets. Spreadsheets are a very common decision support tool. They help reduce cognitive load by doing the actual calculations. And it allows us to do a lot of what-if calculations. I know, for example, that a lot of times if I'm looking at alternatives, I will just go ahead and copy my first sheet over and over and put in different numbers to see what happens if, what happens if demand drops? What happens if the quality is a problem? What happens if, whatever? Now, the problems that are associated with spreadsheets, first of all, if you have a large spreadsheet, you're likely to have more errors. Although people tend to trust large spreadsheets more than small ones. Go figure. You can have incorrectly entered data. You can have incomplete or inaccurate data. Your users will very likely have poor understanding of what spreadsheet errors could be in there. And our what-if analyses can increase the user confidence, but not necessarily the accuracy of our decisions, right? So our overconfidence bias worsens. Okay, so if we're building a spreadsheet, always, always, always check your calculations. Go over that and over that and over that. Make sure that they work out right. Put in numbers that you know the answer to make sure there's not a mistake. Other remedies, have several people inspect the spreadsheets. One person by themselves can miss an error very easily because they've already in their mind said, oh, that cell is all right. Also, using color coding of cells is very helpful. That way we can show the data sources, we can highlight errors, right? So we may be stuck, we know a number is coming out wrong, we might highlight that cell and other cells like it and send it over and say, hey, Fred, can you take a look at this and see what I'm doing wrong here? Another thing to do is hide or lock the cells so that we don't inadvertently get changes in our spreadsheets. that happens to me all the time. But for a but there's a reason to an extent that very often I'm giving spreadsheets out to people who have very little experience using spreadsheets. And as a result, they're kind of screwing around. They decide, oh, I don't like this, I'm going to change it. And we end up with something that looks like, to me, a Frankenstein's monster. All right. Related to spreadsheets are simulations. Sorry. All right, there you go. I couldn't see where I was. Spreadsheets we're already using to do kind of crude simulations, right? And I don't know if Dr. Ramoni has done this, but you can do simulation using spreadsheets to get some of the same answers you can get using a program like Arena. However, a dedicated simulation tool can be very useful, right? So usually those use dynamic simulations where you can test your working hypotheses. You can see if you could meet your goals by these hypotheses and see if your plans are going to work out. Now, simulations don't always improve our decision quality. And why is that? It's because computer simulations can be incomplete. We might be leaving some things out, or they could be inaccurate. We're just slapping down some times and saying, close enough for the government job. Okay, so as with spreadsheets, if we use simulations, we want to be very, very careful we're putting in the right data and that we are building them very carefully and making sure we're not leaving anything out. All right, so that brings us to expert systems. All right, so an expert system can directly specify potential actions. What we have done to make an expert system is we have taken the knowledge of one or more experts and the answers that they give for each situation, and we have put that in a computer program, right? So it's similar to the decision matrix or decision tree kind of an idea, except we, in this case, have just computerized it. All right, so our situational cues are our input. A diagnosis or a suggested action is our output, right? So this helps us to filter our decisions through the lens of whatever expert was consulted to make this. It is a cognitive prosthesis, and it's the most effective if it is applied in routine situations where everything is well defined. It can be a cognitive tool that provides feedback to our decision maker. It helps us counteract our satisficing tendency. everybody reaches a point where they're willing to say, nah, close enough, or good enough for the government job. Okay, so that is, of course, when something is important, we have ample time for our analytic processing, and it brings in an idea called critiquing, where the computer is giving us some alternative interpretations, some hypotheses that we may not have thought of, and some action choices that we may not have thought of. Right? So critiquing can help us deal with unanticipated situations. Now that is assuming that the unanticipated situation to us was not unanticipated to our expert. All right, where am I? All right. All right, so I spoke earlier about displays. Another way of aiding decisions is how we display the representation of our cues. Right? If the cue that we need to pick up on is in the bottom right hand of the display and it's not very prominent, we may totally miss that. So a good display can again reduce our cognitive load of so that we can seek information and integrate that. It can give us alerts that are aiding our decisions about whether a variable needs greater attention. And configural displays can arrange that raw data or our cues so that we can make a better decision. Right? So those cues are more integrated so we can diagnose. All right, so our training is another way of improving decision making. So it can address our decision making at all three levels of control. It can improve analytic decision making to overcome heuristics or biases, focus on counteracting specific types of biases, particularly confirmation bias and overconfidence bias. Now, you may have noticed in your book, though, they're somewhat dubious. They're about that. That maybe that does not work as well as we're given to think. One way we can train people is to do a better job at metacognition. In other words, seeing all the elements that feed into our decision making. So we can train in metacognition so we consider the appropriate and adequate cues to develop better situation awareness. We can check those situation awareness assessments or explanations for the completeness and consistency with our cues. we can analyze the data that conflicts with our situation assessments, and that would allow us to recognize when there's too much conflict between our explanation or our assessment and the cues, and say, wait a minute, we need to start over and thinking this through. And recognize when it is appropriate to rely on automation and when not. And a little thing about that, automation bias is the tendency to rely on our decision aid too much, right? Think, guys, always think what is behind what we are seeing or what we are doing. All right, so our analytic decision-making benefit, first of all, development of better mental models. Often people have a very poor mental model of how a system that they're working on works. Second, management of uncertainty and the time pressure. Some people do not perform well under time pressure. I remember one boss that I had. He and I were both working for Texas A&M at the time, and we were studying for the FE exam. Well, he was a smarter guy, he had more knowledge, he knew a lot, but he and I actually had several classes together. I always did better on the tests though, because he had crippling test anxiety, right? So I would just be taking the test and going through it and really enjoying myself, and he would be in an agony over the time pressure that being in a test brings. All right, so these analytical decisions, when we're training for analytical decision making, the skills should be taught in the same decision making context. When we try and teach people to think in another context, often they have trouble putting that together with the context we want them to use it. Right? So that brings us to the next point, that people are better at learning problem solving or decision making for their particular area. Right? And again, the skills should be taught in the decision making context. So we want to structure to present those concepts in relations to particular situations. Again, people have trouble putting together theoretical knowledge over here with the practical situation over here. If we practice in the practical situation or in a simulation of it, they can put that together better. All right, so when we're on the intuitive rule-based level, we want to train our operators to enhance, first of all, their perceptual skills, that they understand what is going on, increase their situation awareness. Second of all, to train them to recognize the patterns that running a particular system, whether it's a machine, whether it's a chemical system, whatever, they recognize the patterns better of what's going on, and as a result, they'll be able to choose their actions better. Right? So we want to focus on the situation assessment. We want to recognize the critical situational cues. We want to improve their situation awareness abilities. Have them memorize, when this cue happens, we take this action. When this cue happens, we take this action. Right? So QX leads to action Y. QZ leads to action A. All right, so we want to practice trials that implicitly cause people to acquire the rules. Right? There can be some useful learning having them memorize cues and rules to deal with it. But the more often they practice in context again, the better they'll be. So our enhanced perceptual learning and pattern recognition, right? We want our trainees to memorize the rules. Again, our alternative is have trainee practice sessions. And when we're doing those modeling scenarios, we want to highlight the critical situational cues that they either caught or they missed, and the correct action those cues should have spurred. To create better processing at the automatic level, the skill-based level, we want to focus on relevant cues in the raw data form. The skill-based processing is going to take hundreds of repetitions for those associations to be strong enough to be automatic. Okay, so that's one of the reasons that experienced people tend to be more on the skill-based end. But it only works if the cues are consistently mapping to actions. All right, so our rule-based and skill-based simulations are better for practice if they have varied scenarios. In other words, we don't just run the same one over and over and over again. Our decision maker should receive feedback about how they did. So that should be for every cognitive step they took and what was the outcome of the decisions as a whole. Right? But we always have to remember, training can only do so much. Consider task redesign or decision support tools. All right, well that brings us to the end of Chapter 7. On Wednesday's class, we will we will begin on chapter 8, which is about displays. Okay, so again, think in terms of decisions. What kind of decisions, right? Not big decisions necessarily, like what am I going to do to go to college, what am I going to study, so on. But think of decisions that you have to make quickly, right? What do you do if you're coming over the hill and there's a car in your lane because they were passing the other car going uphill? What do you do if your dinner is burning in the skillet? Think of decisions where you have a very time-constrained situation that has to be dealt with. All right, well, thank you very much. Like I said, this is the end of Monday the 13th's class, and I will be putting an assignment on Moodle for you. The link to this video will be on Moodle as well. So thanks very much. Have fun.